Hey, Jenica. So the challenge with using Bayes' theorem is that the math is kind of ridiculous. It's a huge formula. You got to put in all the numbers and then hope you don't make a mistake. And while sometimes we have to do that, um, I'm not a mathematician. I'm a business person, an accountant, and so I try to use other tools when I can. So I'm going to show you how I would approach this problem. Uh, if you really want to get into the math side of Bayes' theorem, we could probably try to do that. But I think it might be more helpful just to let me show you how I would attack this problem. So here's the data set. We have events A and B, and then events C, D, and E. And the way this is set up, A and B are mutually exclusive, meaning A can't happen when B happens, or vice versa. And the same thing, C, D, and E are mutually exclusive, right? D can't happen when C is happening. And it asks us in the problem to find the probability of B given D. They write it in that notation with, uh, B and then the straight line and then D. So whenever we look at one of those, all it's saying is, given that D did happen, what is the probability of B? That's what that means. So here's how I would set this up. First thing I do is I'm going to get my totals, and I'll just use sum. So now I have totals. There's 100 total events between events A and B, and then events C, D, and E. 100 total different events that happen. So again, I'm trying to find the probability of B given D. And another way of putting that is, what's the probability of B happening given that D happens, or assuming that D happens? So sometimes, to make it easier for me to think about, I'll just highlight that and say I'm only interested in event D happening. And so there were 32 total times that event D happened. 20 of them were A, 12 of them were B. And so the probability of B given D then is to take the probability of all the B's that happened while event D also happened, and divide it by the total number of times event D happened. And that's it. That's my probability of B given D. I think this problem asks for us to round to 2 decimal points. So I could use this for anything. If it asked me what's the probability of A given E, I would just attack that by saying, okay, A given E, so the probability of A given E is going to be, so I always say the given, so I'm going to highlight that and say the only events of interest I'm interested in is given that E occurs, and then the probability that A happens given that E is going to happen is 18 divided by 57. And again, and one more example is, we could say, what's the probability of C given A? So if a question was worded like that, I would say, okay, the probability of C given A. So again, I'll say, well, what's the given? The given is A, so we're only interested in this group of events. And the probability of C given A would come right here. So I would say this equals probability of C divided by the total probability of A. It would be 15%. I hope this is helpful. If it's not, maybe we should get together and talk, or go over some other things. And if you're really interested in the math of Bayes' theorem, I can try to go through that with you. Like I said, I'm not a mathematician, so I try to use Excel and other tools to do a lot of the heavy lifting for me, even though I do have a decent understanding of the theorems behind it, but not like like my daughter, who's a math teacher, she loves all of that, all of that, all those theorems and things. Whereas I just see it as a tool to try to figure out what I need to know. Anyway, good luck. If this still doesn't help, let me know, and we'll try something else.